Okay, so let's talk about enthalpy and the Hess cycles. So first let's understand what is enthalpy. We know that there are two types of reactions in chemistry. We know there is exothermic and endothermic. As we know from the words exo meaning outside and endo meaning inside. So exothermic gives heat energy out, and endothermic reactions give energy in. Now the graphs for exothermic will be something like this, and the graph for endothermic would be something like this. And it falls so low because the energy is given out, and so there is so the temperature falls within the solution, whereas endothermic takes the temperature in, therefore the temperature is much higher. From this, from these two reactions, we know that this is from here to here is the activation energy, which I'm going to label as EA, and from here to here is the enthalpy change. And I've just labeled the axes, and and for endothermic the activation energy will be here, and the change in enthalpy will be from here to here. So now let's go over the definition of enthalpy. The difference in energy between the reaction and the surroundings is called the enthalpy change and is represented with the simple delta H, which we have represented here. And so now that we know what is enthalpy change, let us see the formula for change in enthalpy. So it is written as delta H is equal to enthalpy of products minus the enthalpy of reactants. And this is the basic definition. Now, now that we know what is enthalpy, let us find out what are the standard conditions in which enthalpy can take place. So the standard conditions are represented by theta, which is in such a symbol. And the standard conditions are all substances in their standard states of matter. It has a temperature of 298 Kelvin or 25 degrees Celsius and has a pressure of 1 atmosphere or 101,000 pascals. So let me write that this is standard conditions. Okay, so now that we know what delta H and theta is, let's move on to the different symbols that can come. So we have delta HF and we have delta HC. So let's start off with delta HF, which in which F stands for formation. So this is basically standard enthalpy change of formation under standard conditions. So the definition is this is the enthalpy change that occurs when 1 mole of a compound is formed from its elements in their standard states under standard conditions. Now let's understand this definition further. If I want to make CO2, we know that it has carbon and it has oxygen. So carbon in its standard state is C and oxygen in its standard stage is O2. Now, what I always think of is that CO2 is the holy one. We cannot manipulate um, this holy compound, whereas these are all unholy. Therefore, we can, manipulate them. Let's look at another example. Let's take let's take carbon monoxide, which is CO. Now, in this, we know it's made up of carbon and oxygen. So, carbon in its standard state is C, and oxygen in its standard state is O2. So, talking mathematically, if I want to make a 2 into a 1, I have to multiply it by half so that the 2 and 2 will get cancelled. Similarly, if I want to make 3 if I want to make 3 a 1, I need to multiply it with 1 by 3. And so here we can see that there are two oxygens, but here there's only one. Remember that we want to keep this compound holy, and so we will try to manipulate this to balance it. So because there are two oxygens on this side, to make it one, we have to multiply it by 2. Therefore, this is one oxygen and one carbon dioxide, and so it's balanced. So this is all about standard enthalpy change of reaction. And now let's look at standard enthalpy change of combustion. So this is how we would represent standard enthalpy change of combustion. There would be a C instead of an F. So now let's read the definition of standard enthalpy change of combustion. This is the enthalpy change that occurs when 1 mole of a substance, undergoes complete combustion in oxygen under standard conditions. So, by its name combustion, it means that it has to burn in oxygen. Let's take a substance such as CH4. And this burns in oxygen to give carbon dioxide and water. When you burn something, it always gives out carbon dioxide and water. And it is important that you write the symbols as well. So now we want to balance it. In this case, the substance which is holy is this. Anything that burns with oxygen, that substance is going to be the holy one. And for standard enthalpy change of formation, the one that is being divided into its elements is the holy one. That's how you identify what is holy and what's unholy. So let's try to manipulate all the unholy ones. So the way I like to balance this equation is by writing down what are the elements that I have on this side. So I have a carbon, I have a hydrogen, and I have an oxygen. And I'm going to draw a line so that this stays as it is. And on this side, I have the same elements. I'm going to write them in the same order just so that it's easier to visualize. So let's count the number of carbons on this side. It has 1. So I'm going to write down 1 here. There are 4 hydrogens on this side. So I'm going to write 4. And there are 2 oxygens on this side. So I'm going to write 2. On this side, we have 1 carbon. We have 2 hydrogens. And we've got 2 plus 1, which is 3. So I'm going to draw another line because now I want to make these equal. So once I add a number, these values are going to change. Therefore, I need a new space to write so it's much more clearer. I've got let's since a carbon is balanced, we're going to look at hydrogen. It's usually in this order. The elements that are new, this could be magnesium, this could be sulfur, this could be anything. Then comes hydrogen, then comes oxygen. Always balance the oxygens last and the hydrogens the second last. Don't try to balance these in at first. So let's start with carbon. Carbons are balanced. So then let's look at hydrogen. We've got four hydrogen on this side, but only two. So now what I'm going to do is I'm going to multiply a 2 here, and therefore our values are going to change. So we've got, there's only one carbon here, so it stays as one carbon. And we've got four hydrogens here, and we've got four oxygens here. So uh, now that we have four oxygens here, sorry, I'm writing this in the in the wrong place. It should actually be on the other side. Sorry about that. It should be four, and so now we have two and four. So now our hydrogens are balanced. Now we have four oxygens on this side, but we have only two oxygens on this side. So let's add another two to balance it. This is 1, 4, and 4. Therefore, this equation is balanced. So this is standard enthalpy of combustion and how to balance such equations. Now, let's take a look at the last standard enthalpy, this last type of enthalpy, which is the standard enthalpy change of reactants. And this can be represented by the equation standard enthalpy of reaction is equal to the sum of standard enthalpy change of formation of products minus the sum of, this symbol means sum of, standard enthalpy change of formation of reactants. And we will look deeper into this in the next part.